Hello, everybody. How's it going? Are we live? It looks like we are live. Can I hear myself? Going. I can hear myself. We're live. Hello, everybody. Welcome, welcome, welcome. We are streaming. We are officially live. It's been so long. Hey, we get to make the announcement. And guess what? It is now part 20. It means I've probably sunk 60 hours of my life or more into this compiler. 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 I think that's a good title. We'll do part 20. Looks good to me. We'll make that announcement. And as usual, that's my reminder that my phone is not on silent, but the notification has gone out. We are officially live. Twitch is bothering me now about my mobile dashboard. Thank you. That thing I don't use will be so helpful to me today. Alrighty. Let's just get right into it. Hello, everybody. Welcome. And let's get started. Stroma 2022 Fun Compiler. Let's see. And then we're just going to go to do.org. And then source and main.c. Seems like a good start to me. Alrighty. This is a good start. We have a to-do. What do we got? We have a lot of stuff to do. This is probably important. That's definitely something we should work on. Okay, so we got a lot to do. Parsing and codegen of if. Oh yeah, we need to handle the contexts of if. Okay, that's true. So we have a lot to do. First, I believe we have a bug that we were dealing with at the end of last stream. And I believe if we run the compiler right now, it will not work. So let's get a build command up and running. We're going to use cmake and build our debug directory. We're going to run our built executable, and we're going to feed it our, I don't know, let's feed it like our pointers example or something. LandRXT says, last stream? This is your first ever stream. It was all a dream. Thank you so much, Landar. I appreciate you. It's so good to have you here. How's it going, Landar? Thank you for tuning in. It was all a dream. It's true. Oh, I did this from the wrong spot. Run that from here. Wonderful. Could not get variable within context. And the issue is that could not get variable A. So let's take a look at our point. So we have defun foo and we have defun bar. So there should be two scopes within this file, if that makes sense. And let's take a look at what we have. We should have the global scope with two child scopes, is what I should say. So we have the global scope, which has types, variables, binary operators, and functions. Boo, boo and far, bar and foo. And you'll notice something curious. They are not ordered in foo bar. They're ordered in bar foo. And the children of said global context, right? We have symbol pointer, which is a pointer to an integer, but that's just bar. So I don't actually see the context for foo here. There's no context, right? We only have one context, it seems. So there's some issue. First time chat from a viewer, YoshiBoy18303 says, yo, how are you doing? With a follow as well. Thank you so much, YoshiBoy. I'm doing okay. I just woke up. It's the morning for me. It may not be for you. But yeah, I just woke up and I'm getting right into things. We're working on our compiler, which has some major bugs right now because we worked on overhauling parsing of functions, which turns out is kind of complicated. Alrighty. I'm just gonna search for function. Yoshi Boy says it's getting close to noon for me. Nice. LandoXT says hashtag include coffee.h. That's right. Roast a little bit of beans, tropical beans, and feed them into your stomach and your bloodstream. It works. Damn, we're gonna have like pit boys that automatically inject caffeine. It's gonna be dope. I mean, cocainum. That's what we call it around here. Oh, I don't have my auto hotkey. Oh, that's a problem. Hold on. Roast coffee in camel case. Why camel case, Landar? Why camel case? I don't get it. Why would you not capitalize the first word, but capitalize the rest? Camel case. Camel. The name is even silly. I know, to each their own. Everybody can code how they want, but it's so silly to me. Like, I don't get it. What's the thought behind not making the first one not capitalized? I'm trying to find my auto hotkey script. If you would not. If you were confused why I'm just doing nothing here. That's better. Now my caps lock is my control, and I can actually navigate with the home row. So effectively, we create a context, hopefully somewhere around here. Hopefully somewhere around here. Do we not? Where do we create a parsing context? Let's just take a look. We create one here, which is where? Okay, here it is. That's in Lambda. Okay, yeah. Old code that probably doesn't work anymore. The next one is within defun. So when we parse an opening body, a curly brace open, we get a new context, and we say, okay, make it a child of our current context. So then we set up stack for defun body, no param parsing needed. Don't the parameters have to be parsed into the context? That's a little confusing. I like typing git commit way too much. I made a repo yesterday and already have 56 commits. Wow. If you check out some of the days I worked on the OS, there's like there are literally days I did 100 commits, which is insane. Yoshi Boy says, I might just code in Dart while I listen to this, if you don't mind. Of course. We will be going slow today. The plan is to do a short stream and a chill stream. I don't have a lot of time, but I also don't want to rush through this. I just want to get some work done on our amazing compiler. But it's definitely going to be a little bit. Landar says, I'm coding in C right now, actually. That's awesome. RPWH _ says, yeehaw! How's it going, RPWH? It's great to see you. Thanks for tuning in. Landar, what are you coding in C? What are you working on? I'm curious. So it seems like we should probably create a context here. Because even if we get nothing, we still want to create a context. So this is type parsing. Body parsing. Okay, yes. It sounds like body piercing. That's kind of funny. Create new scope for function body. So we do one here, but we also do one here. Why? Why don't we just do it before all of this? Yeah, I think that's the way to go. We're going to create a function context here for the function in general. If Okay. We're simplifying some things. Okay. So if it's not found, we expect one. Right? No. Because this is checking for empty. That's what this is doing. Okay. We're here. We made it. Lander XT says nothing at all. Well, that's the name of the text adventure style game I'm working on. Nice. You got me at first. You had me on the first tab, not gonna lie, not gonna lie. I gotta check my email. Oh, Christ. Okay, we're good. We're good. We're good, chap. We are good. Okay, so I vote that we work on parse type with all the arguments, but that may not be the best idea. We should probably just try and get it working first. So it seems like we have one function which has no parameters. We have one function which has one parameter. So these should both be stored. See, they're stored kind of improperly in the environment. We don't have the proper parameters, first of all, right? Oh boy. So when we store the function in the environment, when do we even do that? Probably here. We store this function, which means we just use, I mean, if we create a new binding, we're gonna go do environment. I know I'm jumping all over the place, I'm sorry. We'll, it'll get better as I wake up and remember what this code does. Lando XT says, oh yeah, also the only way to launch the game is through a command terminal, which you launch through your terminal for some reason. Lamau. I mean, there's nothing wrong with the terminal-based game. I think that'd be fun. It might be new to a lot of people. You could get them to download a shell or a terminal. They already download things like Steam and game launchers, so it's not too insane to ask of people, I don't think. That's pretty cool, though. And it could give your, you know, like bars that don't have a sign out front? It's kind of like that. It's like, ooh, mysterious. I want to play it. So if we create a new binding, you can see that we literally just use the pointer. So the environment should be altered as we alter a function, which it does get things added to it. But it seems like it doesn't, the parameters aren't showing up in the environment for bar. Or we only print one level deep when we print an environment. Is that true? Pretty sure it's recursive. What is this? Okay. We do just print one level deep. Okay, so we're fine. Everything's fine. That's a non-existent bug. It's just that this none here is being, that's the only thing being printed out. We don't print multiple levels of children. Alrighty, alrighty. Okay, we're getting back into this. Searching following context for sim integer. It doesn't print out any context, so I have a feeling that debug message is broken. Let's just go ahead and see if we can find that. Is it in environment? Parser? Yes, it's here. And we do an environment print on context types, which for some reason fails, or just doesn't print anything, which is kind of interesting, I would say, because we're not getting type not found. So we're searching a non-existent. So it's probably in a parent. That's what's happening. That makes sense. So we're just seeing the child environment in the function has the child context, excuse me, is looking in the parent environment, but we only print the environment we look in, which doesn't have types. It only has types in the global environment. Okay, okay. LandRXT says my GitHub repo stats. C 78.2%, text 18.2%, CMake 3.6%. Lamau. You been texting? You keeping your texts in a Git repo? No, I'm just messing. I'm messing with you. That's a lot of C. That's good. I think most of mine they end up at like 98.6% C with 1% CMake until I write tests. Then like whatever language I write tests in gets some percentage. Okay, what do we get? What do we get? What do we got? We still cannot get this, and this is during type checking. It's trying to get a variable access return type, and it's trying to look it up in the context, but we're in the wrong context because it doesn't exist. Alrighty, so why do contexts not exist? I'm in environment.c. So now, again, that's in lambda. So now we create a context here. Hopefully we don't do it right away again. Seems like we do. Interesting enough, nothing changes. So we're probably never reaching this code because it's for an empty body, and we don't have an empty body. Alrighty, but it works now. Or is it most likely didn't before? Neg Vorsa, hi everyone, hello. MandoXT says my license.txt is 18% of my repo somehow. Do you have the GNU GPL? Like GPL v3 or something? Or Apache? Apache wouldn't be that big. It is great to see you, Neg Borsa. Thanks for tuning in. How's it going with you? LanderXT says the worst part is that it's MIT. Lamau. That's really funny. That's really funny. Because MIT is like less than a kilobyte. Oh, I'm just blindly searching in this code for how to fix this. So the problem is that when we add a new parsing context, right? We give it a parent, and then we use parse context add child. Which should, we say if parent child next child equals parent children equals child. And then we say if parent children, parent equals parent children. This is confusing. While parent next child, parent equals parent next child. Parent next child equals child. Did we write two different versions of a function and leave both of them in? What did we do here? Am I going insane? Oh, where did that just go? Chat, this code is insanity, right? So we say we're trying to add this child to this parent. So we add the child to the parent here. Like the child gets pushed onto the children stack effectively, right? So parent is going to have, now it would have parent children is the idea. But then after this, we're going to have parent children is going to be a next child of child. And then we say if parent children, that thing we just set to this pointer. What is this? What is this? Negvorsa says fine, just staked with some code. Like pissed at it? Does that mean like you're cross? You're mad? I've never heard staked before, describing an emotion. Or maybe it's stoked? Maybe you're excited? I'm sorry. I'm dumb. You're gonna have to help me out. Lander XT says there's been a grand total of 2 unique visitors to my GitHub page. You're reading that stats page, I see. Negvorsa says stacked blocked. Stacked blocked. Are you... oh god. I wish I was less dumb. Yeah, I think what you're saying is we have 2 blocks of code that are stacked on each other, that are the same thing. Maybe I'm wrong. You'll have to let me know. So this adds it to the end of the list, and this adds it to the beginning of the list. So I'm pretty sure that we would just like to remove adding it to the beginning of the list. Yeah, great. Great. We now have, hey look, chat. We got different errors and we actually fixed the bug. So now we have foo, which has pointer and a as local variables. Foo, pointer and a as local variables. Then we have bar. I really got to print these out better. Bar with pointer as a local variable. Landar XT. Imagine getting different errors in 2022. Landar XT says, I stick with the same errors for hours. I'm loyal. Lamau. Okay, so now we're failing not on type checking, but on code gen. So let's figure out what errors we're getting. Invalid AST. Could not find variable declaration in environment. We're looking for the variable symbol A. Well, I hate to tell you, but when you're code-genning a variable declaration, you're not gonna have, this is confusing. We're looking in the wrong one. We're code-genning what? Int 0. Okay, now I know what's happening. Now I know what's happening. Chat, we're doing it backwards. That's what she said. But chat, we're doing it backwards, end to end, as they say. We are generating global functions. Global functions. Hey, look, I already solved this. I'm sure 2 days ago, but I don't remember. This iteration is backwards. Might as well just generate global functions as expressions as we see them in program. Well, that's an option. It's less efficient. Because then we're going to have to jump over the function definitions. So I think the true answer would be... We could iterate backwards, but I don't want to do that, because we'd have to make a new linked list. We could... just add functions differently into this environment. So when we add a function into the function environment, we just need to add it to the end and not the beginning. See, we have bar foo here. We need foo bar because this is in foo bar. And that means that as we encounter functions in the program in nested scopes, we'll be able to handle them accordingly in order. So we need to add this in the proper order. So when we add a new function in the parser, so this is going to be what? Context followed by function. Okay, what do we got? I didn't do lazy searching, but it's fine. So context followed by function. Bind function to function name, and this binds function to function name. Where is this? This is in defun. So we do an environment set on line 1300. But we already did one on line 1100. So we're definitely okay on that. Right? Well, I'm pretty sure all this code doesn't get run. This is just old code. Yeah, so this is all dead code we could remove. Because there's a continue following a continue. We're going to remove the dead code, everybody. Probably something worth it. Okay, so we still have the same issue where we add them in the wrong order. So when we environment set, we're going to have to write a new environment set end or something. Yes, environment set end. Give me this declaration and we will create a new bippity boppity with some documentation. And we're gonna say exactly like environment set. Except it adds the child to the end. Pretty easy. Okay, so now how can we do this? When we create a new binding, instead of saying environment bind equals binding and binding next equals environment bind, we need to get the last binding in the environment. So all we really have to do, since we already, yeah. So if this is null, this is going to be an issue. That is going to be an issue. So we're going to have to say if, yep, not that. So if the bindings, if the environment is completely empty, then we just want to use set and return that. Otherwise, we want to be able to use that as the last binding. So having this last binding will mean that this is not null, because when this gets to null, this will fail. So this will never happen, which means that last binding will be non-null given these criterion. So with last binding, we can now dereference and say that the last binding has a next child equal to this new binding. And that should be all we have to do. We should probably do Palic and 1. This is backwards. There we go. Not the best to assert, but it's fine. So now this should add to the end. So now in the parser, we can just use that. And hopefully, hey, chat. Chat. We did it. Foo bar. Foo bar. Okay, that was easy. Woo! Did it actually work though? Let's figure it out. So, what did I do? I would like to check out CodeGen and see why we're getting all CodeGenning expression with contexts. So, yes, and debugging new function. So when we CodeGen a function, we say cogent expression with context. So every expression within a function we're debugging. This makes sense. So now the variable declaration A looks in the proper environment with the symbol A bound to the type symbol integer. That is perfect. Perfect, perfect. Okay, it's working now. So we can get rid of this. I'm just going to comment it out in case I need it in the future. And look at us. This is now our verbose output of the compiler. Very beautiful. Very beautiful. So it says generated code at output file path code.s. Let's check out code.s and check out the assembly. We have foo. We have some register saving because we don't optimize yet, but we probably need it for this one. I guess I guess we don't. It's a simple one. If we just started doing math, we would need it. Or if statements. If statements really take up some registers. It's crazy. Kind of sucks. In any case, we have a variable declaration of A where we sub 8 off the stack. So if we take a look in the other side, I should make a disassembler with like n curses or something. That way we could have like this in the terminal, have the side by side like sub 8 RSP, and it's right next to the variable declaration. So sub 8 RSP is actually just this declaration part. And then we do a reassignment to 0, as you can see, which is treated as a separate node in the AST, which is why it's printed out like this. So this equals 0. We move 0 into racks, and then move racks into the memory address, dereferenced, -40 offset from RBP. RBP is set at the top of the function. And then we sub 32, then we sub 8. And because the stack grows downwards, that means that at this stack address right now, we can then effectively read 8 bytes, and we'll get the 8 bytes that we subtracted, if that makes sense. If anybody has any questions, let me know. Okay, so also I gotta go load the editor. I should do that really quick. Yes, mode. There we go. Syntax highlighting. Beautiful. That's better, everybody. So now we have, for example, foo highlighted as a function name. We got defun types. This is awesome. Also, I can probably do this. It's not really important, but we can do it. A little bit of indenting to help us out. So we have foo as a function, variable declaration A, variable reassignment of A, I presume, but that's where it is on the stack. So that would make sense. Of A to 0. We declare a pointer. Grammar2Parser says, hello, how are you going? I am going good. We solved some bugs already that we were having a lot of trouble with before. So it feels good. It feels good. How are you doing, Grammar2Parser? Thank you for tuning in. How is your backlaying going? All right, so we have a variable declaration, a pointer, which is a pointer to an integer. We have a reassignment using an address of. So we do the reassignment, but first we have to evaluate or execute the right-hand side so that we can move it to the left-hand side. Assignments are weird right-to-left operators. It's one of the only few. LanderXT says backlang supremacy. You should rewrite this compiler in backlang. It's definitely doable. That's a good idea. And then we should write backlang in the language that it compiles. It'll be like the ultimate infinity loop of self-hosting. Write two languages in each other, and then write the languages in the languages they compile. You could just keep going back and forth. That's crazy. You could have codependent compilers. Oh lord. Oh lord. You're getting my mind going, Landar. Grammar to Parser Boy says, I've started adding a WebAssembly backend and figured out some problems that seems unresolvable with the current architecture. Oof, I feel you. I feel you. I'm sorry. Just like the way that your current code generation works, it wouldn't work out with WebAssembly. You can always implement like stubs, WASM stubs, which can you can call C code from the JavaScript. Lander says, I just successfully recruited a friend to help on my game somehow. Recruited? Are you an army? That sounds suspicious. In any case, we load the effective address of A, the same address, here on the stack, into racks. We move racks, so this pointer, this memory address, into the dereferenced memory address that we just declared for the pointer. That all looks valid. We have a variable reassignment of 4. We move 4 into racks. Into the dereferenced pointer, so we have a dereference, which is a variable access of putter. So putter is stored here. I wonder if after we're type checked, we don't actually need dereference as a node. That's very interesting. We may not need to care about it. Grammar to Parser Boy says, the problem is that I compile my AST to intermediate representation, and the intermediate representation is without branching and loops, only with blocks, but WebAssembly uses branches and loop instructions. You can do the same thing. It's just a different backend. You could even write a different, you could like transpile your IR into something with loops and blocks, right? I'm not sure how blocks work, but I'm sure it's doable. Because if it can be represented in assembly, you can definitely do it in WebAssembly. They have all the same. It's a very fleshed out architecture. But you're right, it may be an entirely different beast that you have to conquer. Or you have to use a different intermediate representation, right? Or just use your AST directly. You can always use some tricks. But it should be possible somehow. I don't want to take care of it now. I must have focus on the .NET target, then I can bootstrap my compiler. Lol. I'm not really ever interested in self-hosting or bootstrapping. I think that's just like a can of worms I don't really need to get into. I'm fine with writing it in C and having the language be something else. I agree though, I do want the language to be able to write itself in itself. I just don't want that to be my main goal. Grammar to Parseboy says, yeah, but it's so cool and mind-blowing. It is cool. It's very cool. You are correct. It's just, for me, it seems like it wouldn't be ergonomic as a programmer to have to write things. Like, it'd be like writing Lisp, where Lisp macros, where you have to think like, is this evaluated? Then do I have this feature? I don't have this feature, so I'm going to compile with this feature, then I'm going to boot. It just makes everything more complicated. But I agree, it's very cool, and it should be, there's nothing wrong with having it as a goal. I think it's sweet if a language is self-hosted. I'm just not, my brain is too shriveled up and old already. It's like, yeah, nah, that's not gonna work. Then we have a variable access A right at the end here. So the idea is that we create a local variable A assigned to 0, we take a pointer to it, and dereference the pointer. So hopefully A gets updated. So hopefully foo returns 4 and not 0, right? So if we actually run this, here, we need to do this, a shell command. We're going to use as and generate an object file from this assembly. We're going to use LD, the GNU linker. As is the GNU assembler. We're going to use LD into, an executable from that object file, and then let's run that executable. That looks pretty sane, right? Let's try it out. Shell command failed with code 4. that seems like that's what foo should return, and that's how our language works, where it runs the top level as a script. So foo did most likely return 4. We can test it by returning 69, in case it was just a fluke. So now we have to recompile. This will all change. Now we have integer 69, yes. We can run our shell command once more. Hello? Run our shell command once more, and we see shell command failed with code 69. I think I can go to messages and make that bigger. Right there. And before it failed with code 4, in case you didn't see. Beautiful. So we now know that pointers are able to work and be dereferenced. Do you think we can take a double pointer? I don't know. I don't know. So let's have b integer, which equals 4. Right? 42. Why not? And then we're going to have a putter, which would be a putter to an integer. Then we're going to say that is equal to the address of putter. Is this right? I think this is right. So then, okay. And then this is going to be test putter. This is horrible. Okay. We don't have null yet, so we'll just leave this uninitialized. We still have to do a bunch of type checking. So the idea with a pointer is that when you dereference it, you get a pointer. LanderXT says, I just clicked on a tutorials point link. What is my sentence? Lamau. 10 years. Actually, no, just one programmer bonk. VMe says, what's up? What's up, VMe? How's it going? It's so good to see you. Thank you for tuning in. For those of you who don't know, VMe is a very positive character around here. He's so funny. And we love him. We love him around here. VMe says, how are you all? Pepe hi. Hello. Pepe wave. Okay, so the idea is when we dereference a pointer, we get a pointer. So we should be able to assign this. So we're going to assign our test pointer to the address of B, right? Then we're going to say pointer, dereference that, and assign that to test pointer. Ooh boy. So now our pointer, which used to equal the address of pointer, should now equal the address of test pointer. No, that would set... This is so confusing. So because we're dereferencing it, how do we do this? We're dereferencing this putter, but where does it point to? It points to the address of putter. So we're setting this putter to test putter. That makes sense. So then putter is equal to test putter. And then we would effectively say, okay, because putter is equal to test putter, when we dereference it and return A, it should not update. So A should be 69 still. Even though we've done this, because even though we didn't reassign pointer, it should have been dereferenced and reassigned here. This is so complicated. What do we get? Type of left-hand side variable reassignment must match right-hand side return type. For what? Variable reassignment of putter to the address of putter. What's the address of putter? We get a pointer. But left-hand side putter says it's just a singular pointer. Is that true? Is that what you say? Putter says it's a singular pointer. So maybe we have a bit of an issue in parsing multiple pointers. This is why we did this test, though. So yeah, it seems like we are not getting the proper... Vimi says, at Eternal Wildfox, the OG universe engineer is also here. Yes. Vimy says, Lander XT, good evening, sir. Yes, welcome, Vimy, welcome. It's been an odd morning, but we're getting through it. So it seems like we can't declare pointers to pointers to pointers, so let's go fix that. Alrighty. What do I have to do? What do I have to do? In our parsing, type parsing. So again, we need to work on our return type effectively of what? We should also get rid of this lambda code. It's so old it probably doesn't work anymore. So we probably don't want to have that in there. But we'll leave it for now, for no reason. We do check for unary prefix operators right up here. See? So we're good there, we're good there. So in defun, I guess it wouldn't be in defun, it'd be a variable declaration type. Where is that? Variable declaration. It's somewhere around here. Declaration. Here we go. Variable declaration. So when we do this, we set its type to type for environment. And type for environment is type value with its last child set to the symbol instead of the type value itself. That makes sense. So when we look at type value, we get it. We say while current token dot beginning is equal to at. So is at a delimiter? At is a delimiter, so we should only get a single at a time. Yes, so we should only get a single at per token. So when we lex advance, we shouldn't skip to integer right away. Right? Hopefully. Because we would just skip white space. Let's take a look at how the lexer works. So we skip white space here. And then we check for the end. And then we say, if there's a comment at the beginning, do a thing. And then we say that end is equal to the Storsispen. So the string that does not contain delimiters, the length of the string that does not contain any character in delimiters. So if there's an at, this should be 0, which means token end would equal token beginning, and we get token end plus 1, which means we get another at. This makes sense to me. This makes sense to me. Because source will point to the, yeah. Let's go back through our ats. Is this variable declaration? Where am I? Somewhere. I think this is better. Yes, this is better. This is better. So, ow, I just hit my knee. Hopefully that wasn't loud for you boys. And maybe one grill. Maybe. Advance the lexer. So, interestingly enough, this isn't working as it's intended. Can I print, like, a count? I think that's all I need. Just, like, something simple. Yeah. See, we never loop more than once. That's a big issue, considering our program definitely loops more than once. So I think our lex advance may not be working how we're expecting it. So let's print out our token when we get here. What'd we get? 0. Oh. That may be important. Lol. You never incremented counter. Neg Vorsa, you are so good at catching my bugs. It's so good and so embarrassing to have you around. So we'll print it here. Why not? Because it should, yeah, I guess we need to see it after it advances. So we have 0 with integer, 0 with integer, 0 with at, 1 with integer, 0 with integer. How does that work? Explain. Let's put some new lines in, just to have less of a stroke while reading this. So we have 0 integer, 0 integer, 0 at, 1 integer, 0 integer. What type annotations are these? So these should be variable declarations only. So this is A, which is an integer, B, integer, pointer, add integer, test pointer, integer, and then pointer, what? So we have variable declaration pointer. We have variable declaration test pointer, but they don't seem to be reflected in the same sense. How are we not, what? So what is its type? So a pointer just is a pointer to an integer. What? How's that the case? So how is this the case? You would think that every time we get a variable declaration printing out how many times we get a pointer, we would get all the times that there are pointers, but it seems like we're not. So let's just do something like the current token here. Why not? Why not? We get integer. Okay, that's very hard to read now, so we're going to put this here. Perfect. So we get integer, which is followed by integer, which is followed by 0. So this means that we actually have a pointer to an integer. That makes sense. This is starting to make sense now. Okay. I'm getting it now. I read the tree wrong. So we have an integer. Yes. We have an integer. Yes. We have an at. Not a type, but it is a pointer to an integer. Yes. Pointer to an integer. Yes. Pointer to integer. Yes. Putter is equal to test putter. So what is this? Oh, this is pointer integer down here. Not too insane. Okay, I'm getting it now. Chat, we're getting it now. So we set type value iterator type to pointer. We allocate a new child. We set the type value children. Ah, did you catch it? Chat, did you catch it? Vimi says not too insane. Yeah, it's still insane, but it's not too insane. These 3 characters were the reason we were hunting down that bug. So we have an iterator that we increment, but then we were setting the child, not of the iterator, of the top level, which means that we could only ever get 1 level of pointerism. I like pointerism, that's a fun word. So now if we recompile, ooh, chat. It worked. Do we have a pointer to a pointer? We do have a pointer to a pointer. Okay, we fixed it. We're gonna have to fix that everywhere. So that's what we'll work on next. We'll make this type parsing code its own thing. That's what we'll work on next. For now, Vimi says, please repointerize your code. Lamau. Okay, so now we just want to run this and see what the hell happens. Failed with code 69. Wait, chat. That's what we wanted. It works. Yes. We are victorious. We can dereference a pointer, which points to A, and make it 69. Then we can update that pointer through the use of a pointer to a pointer. Dereference to another pointer, which points somewhere else. And then dereference that pointer. And it doesn't update. Oh, chat, it works. Aye. Lander says when you want it to fail. Negvorsa says no way. I know it works. Pointer to pointer. We could probably have any amount of pointers. This is so good. We just have to fix fix our code now and remove the code duplication that we're doing. This is awesome. And if we call bar, of course, let's just make sure that invalid arguments. That makes sense. We need a pointer to an integer, which means that we would need an integer, which means, yeah, we can't do that yet. We'll get there. But it means that we are doing that correctly. So then can we dereference, okay, here's the next test, right? Here's the test with bar. And it would be, can we create an integer? So we're just gonna say number, which is an integer. We'll set it to 0. Vimi says failure wasn't achieved. Pepe, wait. We're never gonna sleep at night. Then we can have pointer. I guess I should do like numpointer? Sure. Which is a pointer to an integer equal to the address of number. And then we want to pass numputter to bar. Bar will dereference the putter and set it to 69 as we do. And it will return 0. And then we will return number. So if this works, this should return. Also, I should probably just move this. If this works, we should return 69 because we pass a pointer, which points to number. We dereference that pointer, and then we go, okay, return the number that it points to, which means it should be 69. We're getting some more complicated programs. Compilation exited abnormally with code 5. I have a feeling it did not work, chat. Failure was successfully achieved. Could not get type info from type's environment. Huh. So it seems like that's fine. That's fine. That's not a good thing. So do we need to do, like, does that fix it? That still doesn't fix it. So we have number and numputter. They should be in the global environment as variables. And look, here they are. Numputter, pointer to integer. Number, an integer. Looks valid to me. Looks valid to me. So then it says type null. Could not get type info from type's environment. Well, the type is null, so it would make sense. So this is probably a pointer that we're not handling properly in CodeGen from somewhere. So CodeGen isn't handling types in the proper way because it's just looking for, like, it's treating it as the symbol, which is the only thing we had to deal with before, but it may be a pointer to a type symbol, which is what we have to deal with now. It says could not get type info from type's environment. So in the global scope, there's some sort of issue. We could honestly debug it. Do you want to debug, chat? Are you okay with debugging? Should we move on to something else, like working on type checking? How does everybody feel? Should we make the parser better and make the type code all one thing? We could try it. We could try it. Let's do the type code thing. Let's not worry about a debugger right now. Debug, more like bug hunt. You're right. It's more like a suggestion hunt, right? It's nothing crazy. We don't need to keep track of all this crazy stuff now, by the way. In any case, we can get this working on another day. For now, this works. And putter's working is kind of just as badass, I would say. We still print some stuff out. God damn it. I did it. Okay, we did it. Chat, we did it. Very awesome. Whoops. No. And does this code work? It does. Failed with 69. Okay, we did it. So now let's try and get this type parsing. Vimy says, feel the bugs through the force. That's right. I'm going to be like Yoda.
There is no try. Do or do not. D or debug.
That turned into Kermit at the end there. Kermit Yoda would also be just fine. Sith Yoda or Sith Kermit would be fun too. Staring at himself in the mirror. So we would just like to have a node pointer, which is our type value. And we would like to have one which is our... So maybe let's just call one our type and one our type symbol. Is that okay? We already have type symbol. Oh, Christ. Because here's the thing. We're going to need, as for a type, we need one type that has like pointer to the actual node with proper type in node.type, right? But then we need another one, a pointer, apparently, a pointer, which points to like a symbol with the name of type, right? So let's have two nodes, and this one will be type name, and that's going to be this one. And then we're going to have type, like what should this be? Maybe we'll just call it type. Yeah, we'll do that. So then we want to parse a type, which is going to return an error. And we would like to parse the type, probably with a bunch of stuff, but into type name and type. We're going to steal these, go to parser.h, and write this somewhere. Something like this. Perfect. Parse type. Yeah. This seems valid to me. Negvorsa says pointer also need to be copied by value, right? Negvorsa says when passing argument to function, how do you copy value or adjust stack? I'll show you. So at the bottom here, when we call foo, I guess it has no arguments. Do we have something with arguments? We do. Who knows if it works, but we do. Let's try it. So we would like to compile simple. Lots of errors because I broke things. That's right. Yes, thank you. Exited abnormally with code 5. So you're probably, you have something to... we can't test it for some reason. There's some issues with something here. Is it the function call? Nope. We're getting there. Lamau. Value of a pointer is a pointer, so Lamau. So when passing arguments to function, how do you copy value or adjust stack? So for actually how, you can go to a function call, and you can see that for every, we push arguments onto the stack, and then we just use stack addressing using offsets from the base pointer to actually, where is the offset set? Probably in the context when we did the function itself. Yeah, so probably in codegen function. And then, yep, here it is. So in the parameter count, we go through each parameter and we basically push them onto the stack and assume each one is 8 bytes for now, which is not great. We need to get the type of each parameter and get its size, and there's some stuff to do. But yeah, we just push it onto the stack using, yeah, just some basic push it onto the stack technology. Push and pop. Alrighty. So, as for where we were, yes, we were here. So, we want a type name and a type. We want parse type to take in what? Probably at least a context. And then we're going to need the two answers. So we're going to need type has this form, any amount of pointers followed by a symbol. Oop, wow, went to the GNU Emacs news. And then we're going to say type name has this form. Why not? Type name. Type. Coolness. What else do we need? Probably the current token and everything. So let's think about that while we write it. Okay. Vimy says, can't wait when your mad brain will decide on adding classes. Oh god, no. The type checking involved scares me. We are not powerful enough. Okay, so to parse a type, let's figure out what we do. First of all, there's a lot of stuff here that we can probably just copy and then alter, because I don't think we need to rewrite this. I think we're not going to include this part. We're going to assume that current token points to a place, and we're going to end with it pointing to the next place. The symbol, I guess. Well, no, I guess it would point past the symbol. No, it would point at the symbol. Yeah, this is fine. Okie dokie. We're going to copy that, and we'll be back. A little bit below. Okie dokie. I'm just going to go cheat this. Perfect. So type value is actually going to be our type. So this is going to be type. We're going to need the current token. So we're going to have a token pointer, current token. We're just going to call that current. And then I assume we're going to need token length as well, because that's generally how that works. Okay. We're getting there. For parse type, we now need a token and a length. I'm just going to do the same thing. It really doesn't matter. So we're going to use current, and use length. We also need end to end our current parsing expression. So we're going to have a char pointer to end so that we can update it. That should be fine. If length is 0, we use current and length. We use type itself. Alrighty. Alrighty. I don't know if this makes sense yet, but we will see. Lander XT says, I casually have like 20 tabs open on each of my 2 windows. Oh lord. Sometimes you gotta do what you gotta do, you know what I'm saying? Lots of bugs. Oh, just conflicting types. So what did I not add? The char pointer end. I didn't call it right now, so we're gonna need current token. We're gonna need token length. Those are both pointers. So we'll use the address of, and then we need end. Type name and type. That's good with me. Sure, we'll do something like that. Close. Type of left-hand side variable reassignment must match right-hand side return type. So the left-hand side type of putter is now not a putter, which is quite the issue. And why would that be? Probably because type name never gets set. So type name, maybe we don't ever need the actual type itself. When we lex advance and we get the word integer and it's a symbol, we validate the type, but we don't do anything with that. So maybe we don't need this double return type thing. We'll just return the symbol. Right? And then we can just say type value it children. And this could just be type iterator, and this could just be type, really. Oh, do you hear my voice already going? No. Negvorsa says, sorry I missed the pointer episode. I still can't get it. Case 1 argument is defined before the function case 2 argument defined after what? Defined after function. Is there any difference? Case 1 argument is defined before the function. Case 2 argument defined after function. Is there any difference? There shouldn't be any difference. No, because it's not about after or before. It's just about what scope it's in. This is in the foo scope, right? So local pointers work, obviously. So maybe global, it's probably just has to do with global pointers, because this is a child scope of the global scope. So to get like a type, it has to go up to the global scope into its parent and get, oh, that's an integer type from the global scope, because we didn't define integer in this scope, if that makes sense. So I think it has something to do with the code that goes up into the parent. It probably doesn't check for the global scope, the actual case, because we were doing so much work with pointers in functions that we didn't test them on the global scope. But you're right that it probably doesn't have to do with before or after the function definition. It just has to do with this is in the global scope, which we didn't handle properly, whereas we did handle it in here. And it could be something with this, but this likely wouldn't break anything because this is actually a variable declaration, which is the same thing as here. And I'd be surprised if a variable declaration here broke and a variable declaration here didn't. That would be confusing. So effectively, we say go all the way until you reach a type symbol. Write that type symbol into the very last piece. And then type should be done, but first validate that the symbol is proper. And say there's an invalid type error if it's not proper. I think that is completely worth it. So let's think about that. So now we need to parse type. It turned out to be not that bad. Can even fit it on one line. Negvorsa says thanks. Absolutely, absolutely. I'm here to help. So the idea would now be that this type we can use however we use this type, which would be, I don't even know. We get the type here. So then this was all type stuff. Probably in slightly the wrong place. So we get the type. Of the variable declaration with an unknown symbol. We make sure that it's not a redefinition of a variable if we parse a proper type. And then we say variable binding is shell node for environment value contents. Yes, it is. Variable declaration, we say type for environment is equal to ideally just type, right? What else is type used for? I don't think this return type is used anywhere else. So can we not just have it owned by this? We're going to be breaking a lot of things here if it doesn't work. But it did work. Chat, it worked. Thank anybody that you would like to thank, because it worked. Do we still have types and stuff and they're not just all none? Pointer, 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 test pointer, pointer to integer. Yes, it's working. Chat. Yes. Okay. It is working. Check for initialization after declaration. Yeah, that does that whole thing. I wonder if this is our issue. Interesting. Maybe our address of unary operator was the issue in our point. Interesting, interesting. In either case, we seem to have moved parse type into its own little thing. So now let's think about where we use parse type, or where we could use parse type, I should say. So here we are within a what? This is within a function definition. And we effectively would like to parse the return type of the function if there were no parameters. Yes. That's pretty valid. So parse type with all the arguments starts there. So let's just do parse type with all the arguments. Probably should have like commented that stuff out so I don't get super confused. But hey, you know, you only live once. You only code once. That's not true, but it can be. Whoa. There we go. So now we can just parse the return type. Sure. Do functions still return values? Still return types. Function, integer. Perfect. Can we now do something like function pointer integer? We can. So now a function can return a pointer to an integer. Okay, wonderful. Much better. So where else do we parse type? We're gonna have to move no, it's in the header. We're fine. So we have another parse type in when we're when we're parsing a function's parameters in between the parentheses. So we're doing variable declarations. Effectively, what we would like to do, oh crapola, what is this? Okay, I get it now. We're parsing the function return type. So we have to first get the colon, because that's not part of our type, really. That's a type annotation operator that tells us, hey, we have a return type. Then we want to lex advance, and then we have to say parse type. We're going to need a node type, where you want to parse type with the context, current, length, end, and type. Looks good to me. Well, looks good to me. So now we have this type. What do we do with type normally? Node add child to stack body. Yeah, so the parameter list should be, is that right? I guess it's right. Apparently it works. Yeah, that's how we set it up. So we kind of add the parameter list as a child, parse into that. At the end of the parameter list, we add the return type. And then in the body, that's the third child. That's making sense. That is making sense. So now return type parsing is much easier. Do we have any other type parsing? I think that should be it. So we just removed a whole bunch of code. That's really awesome. And hopefully, let's see what's broken. Or try and see what's broken now. So does this work? We can define a function just fine. We can define variables just fine. But there is some issue, for sure. And it has to do with the function call, but it has to do with this part of the function call, in which we are dereferencing null, I'm sure. So we have a null type. Null type. How do we get a null type in CodeGen? Right? That's confusing. So we said Parse Get Type somewhere. It's literally only used in one spot. To do the following line causes errors when it really shouldn't. So the error is is apparently known. Gotta love comments like that. I was apparently angry. So, oh, I gotta love it. Gotta love it. What is the issue with this parse get type into temp node temp node? What is temp node? Christ. So we use where are we in? So in a variable declaration, right? Okay, still could not get type info. So we are within a variable declaration. And it says, if not cogen context parent, break. Because global variables are different. Yes, they're, haha. This won't work. We did it. Okay, we found it. This should be our error. Because we were trying to environment get our type, which was our var_it value, but we're trying to look up a pointer which has a null symbol, and in an environment get, I bet you we're not that careful. And we don't say, is ID a symbol? Is ID valid? Yeah, not at all. We just say, do we ever use ID? We do it in node compare. So where is that? That's probably in parser, sadly. We need a types. So for node compare, for a pointer, we just say, hey, node compare pointer. Do we actually see that? We don't actually see node compare pointer. Yeah, no node compare pointer out. So we're not getting here, which is confusing, I guess. So maybe we should just have like something like this. Comparing A to B, I guess. Comparing nodes A and B. I'll just say comparing nodes and then we'll print them out with some indent. Will that work? We do a lot of node comparisons, it appears. Oops, there we go. Just out of curiosity, if any of you want to share or talk, what are your hobbies? What do you do? You know? A lot of symbol comparisons. What do you do in your free time when it's not programming? Or even if it is programming, honestly, I still want to hear about it. Comparing nodes integer and pointer to integer, type null. So this is exactly what I said was happening. So it's good that that it happens, and I'm not insane. So the reason that we never reached our to-do pointer is because A is the type that we switch on. We don't switch on the B type. Here's the thing. So symbols and variable accesses need to be able to be compared. I'm sure it happens somewhere here. Or it doesn't, Lamau. But we need to compare these two, so even if the type doesn't equal, these need to get by. So we need to only check if it's not equal, if the type of A is equal to symbol or variable access, and the type of B is equal to symbol or variable access. Because we only want to compare this A to this B. But then we switch on A type, which means if B is a pointer, we never actually get this message, which is kind of an issue, right? In any case, we have to be able to compare these a little differently, but I think I want to keep this comparison the same, and I don't want to add pointer to this list, because that's not really what we're trying to do. So we just need to figure out where we're calling environment get from incorrectly, which is right here, and then just properly get the type ID. I guess we could do while not type ID value symbol. So this would say, until you get a valid symbol, keep going into the children, but this would keep going even if it's null. So I should say something like while type ID and then I should say if not type ID, some sort of error about misshapen types environment is what I'd say. Variable environment. Yeah. So that's it to do. Need to write that error. So in any case, type ID should now refer to our type ID. And hopefully, hey, look, it worked. Paug. Here's some comparing of things, variable access and symbols. The comparing nodes output is really nice. I'm going to keep that. I'm just going to do this. Actually, really nice debug output when you need it. Okie dokie. So we now have our function. Let's check that it still compiles and everything with as. Does everything still look good? Still looks good. We don't have any crazy numbers. We fixed our stack properly. Let's try it out. Shell command succeeded with no output. I think that's what we were meant to do. Yep. So now, let's run again. Still exited abnormally with code 5. So the global function call is still an issue. But everything other than that now works, so that's pretty cool. Can we like dereference a putter at the top level now? This should return 69. Undefined reference to null. What? Undefined reference to null. Oh no. What happened? No. Ugh. Why? We were close. I thought we had it. So why do we have null rip? We have variable reassignment of what? We have a variable reassignment of numputter to number, which is this, and we assign numputter rip addressed to number. So numputter gets assigned a number, but the address of number, that's valid. Then we have a reassignment again, this one, which is a dereferenced numputter, which should just be an address. But this dereferenced numputter gets 69 moved into it. But it doesn't work. Numputter isn't being found by CodeGen? I don't understand. So when we create numputter, did we allocate space? So we have space allocated for everything. We have numputter 8 bytes, number 8 bytes in our data section, our mutable data section. So then when we access them, I gotta check my phone. Oh, I do have to go in like an hour. Okay. Sorry about that. Had to answer some stuff from my phone. So numputter. We move racks into numputter, but when we try and move something into numputter, we get an invalid variable offset. But it's doing rip addressed. So this should just be numputter again. Why is you know what I mean? Let's think about this. Let's think about this. So we generate global variables. So we should probably get this error happening. Some sort of error about misshapen variable type. And say could not get type ID type symbol / ID parsing. Basically, AST must be invalid or misshapen. Sure. We don't get this error, so it's some other issue. Null. Can't believe we're getting null and not caring. So symbol to address. How could it return null? Right? How? So symbol index, if that happens, then we'll say symbol index plus plus return label generate if symbol index is greater than equal to label buffer size. What? Does this make any sense? Why are we comparing to the label buffer? That's a little confusing. Let's think about what this function does. Symbol to address, cogent context symbol, symbol string is symbol buffer plus symbol index. So we have a buffer, a static buffer, which uses label buffer size. It should use symbol buffer size. I don't know if this is correct. So let's think about this. Symbol string equals symbol buffer plus symbol index. So somewhere within this static memory, we have an index saved to the beginning of our next string that we can begin writing. So if we had like the string like this, right? Then we have some pointer that says like you can start writing here, and that's our symbol index. So then symbol string gets pointed to this. And then we say symbol index plus equals the RIP addressing if we're in the global variable accessing. So this is where the percentage %s goes wrong, right? Okay, I'm getting it now. I get it. So currently symbol value symbol before symbol, so symbol needs to be the type symbol, the type ID. It cannot be the type itself. And that I think is where we're making a mistake somewhere. In our code gen, we have code gen that is trying to get a symbol to an address, but it is not passing a symbol. So how we could fix that is honestly by making sure we could say if not symbol value symbol, well, first of all, if not cogent context, that's a big deal. Then we have if not symbol or not symbol value symbol. A symbol must be passed to symbol to address. We'll do it like this. We're gonna, yeah, we'll do something like that. And we will return null on purpose. Right? And then we'll say a similar thing here. Well, cogent context, yeah, it should never be null because we should be past the global context. So context must not be null past global. I know that's not helpful for anybody using the compiler, but for developers changing crap, this will be helpful. Okay, so now we check if symbol is a problem, and we now get that symbol is a problem. It's still not seen as an error because it's not bubbled up. So we're gonna just put a to-do on this and say return error and bubble, but makes it annoying. Right? It makes it very annoying to have to return an error and bubble from symbol to address. But in either case, error will be printed out. A symbol must be passed. So we can print the node that we were passed as well. And we were passed a dereference of numputter. Very interesting, very interesting. So this is a global variable access. What do you know? So right here, we assume that the symbol we're looking up is a symbol and not a dereference. So that's all we have to fix wherever we are messing that up. So it seems like it's near the end. If we take a look at our code, it's near the very end, and it's the variable reassignment address of. So it's a variable reassignment. Probably this one, the dereference. So with this dereference, oh boy, oh boy, oh boy. Hey, I missed a follow. Thank you so much, Biology, as well, for the follow. If you're still here, I very much appreciate it. Lurker or not. That follow, all these follows, they get me excited. You were my 80th follower. That's so impressive. I didn't think I'd ever make it here, especially in 3 weeks. In any case, it looks like a reassignment is our issue. And it's happening. We codegen the right-hand side, which is a 69. And then we say, if we have a dereference, codegen the left-hand side. Otherwise, just use what you got, right? Also, chat. Oh, wait, no. I was like, wait, there's no break. I was like, we need to break, but this isn't another case. This is an else. I was like, there's no break. We were falling through, but we weren't. Everything's fine. Everything is fine. We're just going to remove that from there, because that was annoying me. I guess we are going to have to do it separately in each place, actually, so we might as well just keep that. I screwed up there kind of heavily. Reassign. So a global reassignment, let's see. We codegen the expression of what looks to be the right-hand side. Didn't we already do that? So we codegen right-hand side right away. I mean, no matter what. Unless it's just an integer, right? Which it is just an integer, I guess. So then we say result equals malloc64. What is this? snprintf result LLD. So we just have to get a number. I see is why we're doing this. Then we say expression children next child value integer. Our expression is a reassignment. Children next child value integer. That's valid, so we'll get this as an integer. And then we will write that with a move cue into the right-hand side, and we'll use symbol to address, here it is, on expression children, the left-hand side. So what we should really do is codegen the left-hand side no matter what, right? Is that making sense? I don't know if that makes sense, because this seems a little overcomplicated for codegen of a reassignment. But basically, for local, we have to worry about what? Why is local different from global? So a global reassignment is different from... I'm honestly blanking. How could it be different? You move the register name into the symbol to address, and then you deallocate the register. These are the same, are they not? This is so confusing. Why would I write this in this way? Am I going to figure out like, oh, that's why? Am I going to screw something up by changing all this? Can anybody think of why this would be an issue? Of why we would want to like codegen variable reassignments differently on the global level. Currently, we're handling dereferences only in the local level, which is why we're having issues. So that's not a reason. We don't want this. It seems like this could just go on the global level. What if we just rewrite variable reassignment? Let's think about what we'd want to do. One, we should what? Probably cogen right-hand side. No matter what, we need a register that contains... We need a result, right? We need something to set to. We'll just... I don't know how to say that. We're just going to say cogen right-hand side. We need it. So we cogen the right-hand side. Then we need to do what? Why are we doing this weird if dereference? Because we need to dereference in the assembly or not. And we either need to use a register name of the left-hand side expression, or we need to use... Interesting. So what happens if we cogen an expression of the left-hand side that's just a variable access? Then we're going to get the variable itself, which we don't want. So basically, if left-hand side is var access, all we have to do is symbol to address, right? So we're just going to recurse left-hand side into children until left-hand side is a var access. This may not be very future-proof, but it will work because we can just go, a variable reassignment has a left-hand side. Oop, it's not variable access. Oop, it's variable access. Then we can use numputter, look that up, get the type of numputter, which is a point. Yeah. Do we need the type of numputter? Why do we need... Oh, do we just need to know... Why do we need... Wait, why do we need this numputter? Oh, we need numputter if it's a global... Okay, I'm getting it now. So if it's a global variable, the thing is that we need to use this directly because this is a symbol in the generated code, like here, numputter, right? It's just literally a thing that we can use, like this. So we just need to call symbol to address on this symbol, which means we need the symbol, which means we can't have a dereference. All in all, Christ, what this means, let's just try and get set temp node or something. Do we have, yeah, we have temp node. We should have temp node. Set temp node to the name to the var access node. That's all. Let's make that goal, okay? Because I feel like I am losing it. We can't actually set temp nodes. We're going to have to use iterator for this. Because temp node is an allocated pointer, so we don't want to reassign it. Whereas iterator is null by default, so reassigning is what it's made for. It's an iterator. So this needs to equal the left-hand side, our first child. And we'll say, while iterator type does not equal node type variable access, iterator, we're also going to say while iterator equals iterator next child. Is that how that works? No, equals iterator children. Because if we have a dereference of a dereference of a dereference, that'll be children, not children next child. Okay. I screwed up. If not iterator, problems. To do. And errors. Error here. Because, or invalid or misshapen AST. Hey, Hostman, sorry I missed your chat. Hopefully it hasn't been too long. I've been focused. Hostman says, how is the compilering going? Compiler. Compilering. Adderson28 says, hi, Lens. Hi, chat. How are you doing today? I'm doing okay. We solved a lot of bugs so far, and we're fixing a lot of things. See? That's why we have errors. Okay, so the idea now, with iterator being equal to a variable access, let's think about it. All we then have to do is say, if we are in a global context, then this iterator contains our actual symbol and not, is that correct? Expression children. Hey, we don't have null anymore. Chat, we did it. We did it. We can now just use iterator as well on this side, but I don't think we ever need it, to be honest, because we just code gen the left-hand side. And a dereferenced when code gen returns the address in the result register. So then we can just move from register to dereferenced register. I think that makes sense. I don't think this is too insane. Adderson says, oh, that's good. The day has been productive. Yeah, it's been not too bad. It's been not too bad. I've got a lot of stuff to do later today, so my brain is already like, go, rush. You have no time. So it's been good this morning to try and work on some compiler. Did you see that our pointers are working? Not globally yet, but we have local pointers and functions completely working. So you can have a pointer to an integer, and you can reassign, you can dereference the pointer to reassign the pointer that it points to, pointer, to test pointer, which points to somewhere else, to B. And then when you dereference pointer, you'll actually set B instead of its originally assigned A. There's a whole lot of stuff we can do. It's very cool. We're still working on it, but it works, you know? So we can run it and it returns 69 because we call foo, and we return A, which is set to first 0, then the pointer actually dereferences into A, 69, and then we update pointer using pointer to test putter, and then dereference putter again to 42, which sets B and not A. It's very cool. It's working. We're still working on a lot of things. Exited with code 5 still there. Yeah, so we still have a null dereference in our function call somehow. Okie dokie. But as far as this code goes, we should now be able to succeeded with no output. See, that's not correct. So move number according to rip. See, this variable reassignment, we're assigning the pointer to 69. That's not right. We need to assign the dereferenced pointer to 69. So we need to actually code gen a dereference on the left-hand side. So let's remove this little if. We're just going to remove this optimization entirely. Okay, and take a look at it. So 69 gets moved into racks, then racks gets moved into numputter. But that's not what we want. We want to basically move from numputter rip into an address and then dereference that address. So the first thing that we do is code gen the right-hand side. And this is on both parent and not. So this should be able to move out like this. Okay, let's see what that looks like. So now everything still looks good. We're not doing anything crazy. We move 0 into racks, we move racks into -40. Stuff is still working. But now we are not handling the left-hand side if it's a dereference. So we're going to do this a little differently. And what we're going to say is, let's think about this. So if it's not a variable access, we want to code gen it. And then use our result register. Okay, so I know what to do. We need to set result. Set our result, which is a char pointer. This is a string. So set result to operand that will be written into. Does that make sense? Left-hand side to operand representing left-hand side that will be written into. I think this makes sense. Cyber Patty says, hi-oh. Hi, Cyber Patty. Also, Holy22, thank you for the follow. Thank you so much. I'm sorry I missed that 4 minutes ago, but we are here now. Cyber Patty, how's it going? Adderson says that makes sense. Awesome. Thank you, Adderson. I'm not insane. It's good to know. So, if expression children type does not equal variable access, result will be equal to register name on expression children result register. And this will be after codegenning the left-hand side. Adderson says lol. Cyber Patty, I forgot to ask, how are you going today? What brings you into the stream? I thank you for tuning in. I appreciate it. So result can be equal to a register name if we have to codegen. Else, it should be equal to like symbol to address, right? But if it's equal, okay. Here's the thing. If it's a register name, we have to surround it in parentheses. Oh boy. So we're gonna need like damn. You ever hate working with strings in C? Cyber Patty says, good. Today was full of refactorings at work. Oh man, sometimes that can be good. I'm glad it went well. Cyber Patty says, you pinged in the Discord? Oh, that's why you're here. Lamau. It's true, I did. I made an announcement. If you don't know, by the way, I haven't talked about that today. If you don't know, we have a Discord where a whole bunch of people, a whole bunch of friends are, and we'll welcome you, we'll wave you on in. But I make announcements every time I go live, so you'll never miss a stream. And we all have a ton of fun chatting and sharing our awesome creations, like this Mr. Mugame working on a breadboard computer, which is fucking dope. Looks like he has the clock module in the top left. It looks like he has a lot of space for ALU, because he has one ALU here, it looks like, with the LEDs. This should be like an arithmetic logic unit. But this should be what looks to be EEPROM, like RAM. Cyber Patty says, awesome guitar, Mr. Mugame. That's right. That's the guitar of a lifetime. But yeah, we have a ton of fun. We have a code review section. Hey, we had someone join. Hello, Hostman. Thanks for joining. It's great to see you. I clicked, but it didn't go. There you go.
Hello.
I'm playing with my Emacs. So to do, put parenthesis around result. No? So else, this right-hand side is just going to be equal to symbol to address. Maybe this would be easier the other way around to understand. I just figured out, by the way? That's probably much easier and less confusing. Like, oh, okay. If the child is a variable access, just use symbol to address. If it's not a variable access, code gen it and figure it out that way. So we need to put parenthesis around result so that we can do that correctly. Then I think these are all going to end up the same. So let's figure out how to put parenthesis around result. This is going to be so annoying. Oh boy. We're going to need a result copy. This is going to be awful because we're in a switch case. Hopefully it lets me do this. Please just let me do this and not have to worry about it. So result copy is going to be stir-do of result. And say result equals realloc. Is it even allocated? What is result? I don't even know. Hello? Hello? Oh, result is null. That's wonderful. Looks like we're here. So result is normally null, but it's not null because now it's a register name. So do we realloc result? We don't want to realloc result. We'd want to say result equals malloc. And then we're going to have to free it in this case, which is annoying. So we're going to have like a, again, this is in a switch case. Hopefully it lets me do this. Char should free result equals 0. And you may have guessed, should free result after we malloc will be equal to 1. And this will be len plus 3. Result. Right? So we're going to say needed len is strlen plus 2. We can say needed len plus 1 for our null terminator. Say result at needed length equals our null terminator. And then we should be able to write in basically send printf into result buffer count. So this would be needed len. I think needed len plus 1 is what this would be. CyberPatty says, a hard, honest refactoring is really relaxing, to be honest. That's awesome. It's really cool you're good at that. Hey, Keyber Code, thank you so much for the follow. I greatly appreciate it. Welcome to our Epic Compiler Globe. Alrighty. Now it's a format string and such. I would like to write in parentheses, result copy, free result copy. We're going to say should free result equals 1 up here. Okay. So now result should equal a string with parentheses on both sides. Like this or this. Perfect. Perfect. And this should be, result copy should be equal to the result register. Yes. Yes. Okay, it's working. It's working. So now we should just have to move from the right-hand side result register into the left-hand side. It should be rather easy to omit this code, and we shouldn't have to worry about anything global or not. So we would like to move the left-hand side, which is going to be, we'd like to move the result of the right-hand side. No? So the right-hand side is this. And we want to move the register name of its result register into result. Eternal Wild Fox, hello! Cyber Patty says I could do just that. F features. Lamau. That's really cool that you could do just refactoring. I think it would drive me a little crazy. Wait, did it just work with no errors? That's not okay. Chat, I think it worked. Oh my god. Do you see how much simpler we just made this? That's amazing. We still have to if should free result. Oh, and we have to deallocate the register of the left-hand side. So we're going to do this. Should free result equals 1. When non-zero, deallocate left-hand side register and free result string. Free result and register deallocate the left-hand side result register. Well, actually, we can do that. Can we? I think we can do that here. We don't actually have to do this here. I mean, technically we should. We'll just leave the deallocation at the end. So this will be deallocate right-hand side result register. And then this will say deallocate left-hand side result string and result register, if needed. Okay, so this emits the instruction, this deallocates the registers used in the instruction. Put parenthesis around result, that's something we do. Awesome. Probably about 30 minutes left on the stream. Yes. I missed a call, it looks like. I'll have to get that after the stream. In any case, let's think about this. Go back here. I see an issue. I see a big issue. What's happening here? Variable access putter. We move the pointer. What just happened? All I did was write comments. Eternal Wild Fox, sorry I missed your question. I've been so focused on this code genning. Eternal Wild Fox said, "How are you doing?" I'm doing okay. It's been okay. Negvorsis is where are the parentheses? Oh, I did delete something. You're right. Negvorsis is right. I deleted something. When did I delete something? I thought, okay. Maybe I'm just insane. Did we not have an SN printf here? Like all done? Chat. I'll have to go back in the VOD. That's confusing. It just disappeared. I thought we had result. We had needed lang +1. We had parentheses %s. And then we had, this is so odd. Result copy. Alrighty, that works. Thank you, Negvorsa. You're a genius. You catch my bugs every time. Alrighty. With that done, let's think about what this code does. So we move 69 into racks. We move the address of numputter. So the value of numputter into R10. Then we move racks into the dereferenced address of putter. Yes. I do need, Negvorsa, you're incorrect. I do need Stradoop. Otherwise, this would be an uninitialized mallet, which would not work. You're close, Snake Borsa, you're close. But the no cigar. Still an issue with global function calls, but as far as global pointers now go, it seems to work. Failed with code 69. Yes, it works. Recompile, rerun, failed with code 42. It works, it works. So now we need to figure out why we crash on a global function call. Or not. And we may just need to end the stream, because I'm running out of time. So for a function call, how far do we actually get through before crashing? Oh. Like, do we write code.s at all? We don't write code.s at all. Okay, so we're probably erroring in type checking of function calls or something like that. So let's think about function call. So we get temp node, we get the function that we're calling in temp node, and then we get type like this, and then we return. But to actually type check a function call, which is probably where we're going wrong. Expression children. So that should be the function we call. So get value. Value should contain the function. Temp node. Oh man. I'm getting tired now. I've done so much work this morning. Temp node points to value children children. So this should be the first parameter in the function. An iterator should be expression children next child children, which should be the first parameter. Eternal Wild Fox, you must have typed that in 10 seconds, but I think I get what you mean. Oh my god. I worked out an idea. Doing more ahead. So, okay, I worked out an idea. You're going to work ahead using C++ or C# to gain speed and development for the interpreter compiler, and learn C in the meanwhile. That's not a bad move. You can definitely develop just as fast in C as in C++. It just depends on how you write your C or C++, right? But as a beginner, you're right, it will take much longer. So if you understand those other languages, then might as well use them. So value is going to be a function. So value children children is fine. Expression children next child children. So we have a function call. And we have expression children next child children. So if there are parameters, then that's where they would go. And then you say, okay, while we have expected parameters and while we have actual parameters, keep going. And we get the expression return type of iterator into type. Iterator may be null, but this means that they cannot be null. Interesting, interesting, interesting. Eternal Wild Fox says, I suck on function pointers in C. Pretty much everyone does. which I most likely need for the visitor in C, then don't use the visitor pattern. It's not that difficult. If something's too difficult to do, just don't do it, right? All you have to do to iterate things is say while, right? Just make a loop, figure out how to get to each one. Because a linked list is just while it equals it next, right? And then if you in here have things like if thing, it equals it not next, right? Then you'll go like progress into this, or you could make this a function and call this over and over recursively. There's so many things. There's lots of ways to loop over and iterate ASTs and trees in C without using functions or object-oriented things that aren't really supported. They're supported, it's just not great. Okay. How could we be doing something wrong? So value should be equal to a function. Value children children. Value children should never be null, so this dereference is fine. Temp node children next child. What is that? Right? What is happening here? This may be an issue. So parse get type takes in context ID and result. So we're getting from the original context using this ID. So what is that? Let's say we have a function. Temp node is equal to value children children. So variable declaration sim pointer. Children next child, this would be null. Why are we passing null here? Like temp node, children, next child. The next child should be null. So why are we passing null to parse get type? What are we trying to do? Get expected type of parameter in temp node. So we're going to have to, let's look at parse get type then. What does it do? Parse get type says while context, so search for all contexts. Not bad. So we search for the type's ID. So this is expecting a valid type ID. So this would like get the value of a type symbol / ID in type's environment. Sure. Or return error. We'll say this. Return an error if type is not a valid symbol or ID found in contexts. Perfect. Eternal Wildfuck says, yay, I already figured out how I could iterate into the children. I did something like AST pointer C equals AST.child, while C does not equal null, C equals C.child. Yeah, that would recurse down into the left-hand side forever. That could definitely work. But yeah, that would simplify things greatly without having to use the visitor pattern. Well, it basically is the visitor pattern. It's just not a member function of an object. So when we call parse get type in the type checker, we're calling it on something that doesn't exist. So we have to look up in the context to get the type. No? Yeah. Yeah. So look in the variables scope or the variables environment and try and... Yeah, this is basically what's going to happen. Negvorsa says see dereference child. It's true, Negvorsa, you're right. You are right. It's a pointer. It is a pointer to a struct. You can still access a struct with the dot operator. It just has to be a literal struct, not a pointer to one. All right, I've got probably 15 minutes, so let's get into this. So to look up an environment, we're going to have to do a thing again. And this is going to be like malformed or misshapen parsing context during type checking. I don't know. That's good enough for me. Because this would mean that we don't get anything. So if we do get something, break. And we want to get from context and variables. We're trying to get the type of our variable. So we have a variable declaration putter. We'd like to look up putter in our environment, which is equal to a pointer to an integer. So all we do is look up this thing, and we want to look it up by our symbol, right? What is our symbol? That would be temp node children. And we'd like to write that into result. I don't know, where did we write that into before? Did anybody keep track? I'm gonna check Git. Oh, it's right down below. We write into result. And we're probably gonna have to do this. No? Oh, we just need to get dereference the environment itself. Alrighty, alrighty. Thank you everybody so much for watching. Be sure to check out the Discord down below if you are inclined and interested in this content. We have a ton of fun, and I really recommend joining. We are all friends here. There's also the YouTube down below if you want to check out any previous broadcasts, so I really recommend that. And then there's the donate button. If you would be so kind and so generous, I appreciate any and all donations that come in. And with if you leave a message and your username, I'll read it on stream as long as it is appropriate. So yeah, that should be my little spiel done. I should be able to continue now. So we can move that from a to-do to a to-done. And then we have to look up the type we get. Right? Well, no, this is just our expected type. So now we get the return type of the actual given parameter. Given parameter. So in variables environment for proper type. Perfect. Expected parameter type. Get return type of given parameter, so the parameter that they actually typed in. And then if type compare equals 0, we'll say, hey, you failed. Because if types are equal, return 1. All right, all right. Crash? Crash no more? Crash no more! Now we just say malformed or misshapen parsing context. So, interestingly enough, it says that context ends up being null, which would mean that we don't actually have a variable of the name temp node children, which is a little worrying. So for a function call, we would have to look in the environment of the function, which is a little annoying. I kind of don't want to do that. So before, we just stored them as literal symbols and it was fine, but now we don't. And it's not fine. So we have a variable declaration putter, which is stored in the environment. But when we call the function, there's no way that we have a pointer to this specific parsing context, because we could be in any context and calling the function. So when type checking, we need to store the type information of the function parameters in the actual AST itself, which is annoying. So how can we do this? How can we do this? Or we can do it another way if anybody else knows how we can somehow get the proper context. I don't know. Let's look at our to-do and see what we did. We didn't do that at all. We didn't do that at all. And we did do this. We did make parsing a type easier. We can drop that down the list. That's it. Okie dokie. That was good, huh? So to do, which would be kind of urgent, would be to so in type checking, so we're just gonna do this type checker.c at around line 300 function call type text. We somehow need to access the types of each parameter as we iterate them. But we recently, quite accidentally, well, we didn't accidentally do it, we just didn't realize this was the consequence. So we somehow need to access the types of each parameter as we iterate them, but we recently changed how function parameters are parsed. And because of this, we no longer, so what does this say? We somehow need to access the types of each parameter as we iterate them, but we recently changed how function parameters are parsed, and because of this, we no longer store type symbols / information in the function AST itself, function node itself. I guess it's a function AST because it's a whole tree of nodes, which pertains to a function. Abstractly, that makes sense. So we somehow need to access the types of each parameter as we iterate them, but we recently changed how function parameters are parsed, and because of this, we no longer store type symbols / information in the function AST itself. This means while type checking a function call, I think that's correct grammar-wise. This means, pause, while type checking a function call, yeah, because otherwise it'd be this means we must. So this is a dependent clause. Okay, ookie. This means while type checking a function call, we must what? We would have to somehow know which context it pertains to. We could just store an extra node that points to the environment somehow. Node somehow. But I don't think that's the best solution. Maybe type, I don't know. How should we do this? Maybe we should parse function parameters differently than variable declarations, even though they're the same syntax, just so that we can store this separate information. In any case, we're not going to be working on that today, because we have to end very soon here. I am running late, and I definitely have to go. So what I would like to do is say thank you to everybody who watched today. Say thank you to all those who didn't watch today. I appreciate every single one of you. I will point you down below to the Discord link in the About section. I really recommend joining. It's a lot of fun. Along with the Discord, there's a YouTube link. And that YouTube link has basically every single broadcast I've ever done in the past. So if you want to check out how this compiler got here and how, or any of my previous projects as well, check out the YouTube. They're all there. On top of that, there's the GitHub, obviously, where everything, all the code is open source and available to you, so you can build and run this on your own machine. And finally, there is the PayPal donate link in the About section of Twitch. I would greatly appreciate any and all donations. I don't have many sources of income, so it would greatly help me out if that were to happen. If you leave a message, I will read it for sure, and I will read it on stream if it's appropriate. If you leave your name, I'll attribute it to you and say how much you donated and do the whole Twitch donation thing, right? With that said, it is 10:30 in the morning for me, as you can see, and it's time for me to go. I gotta start my day and get some work done. So thank you everybody so much for watching. I had a great time. We made some great progress today, and yeah, I'll see you next time. Be sure to hit that follow button on Twitch too. I forgot to tell you about that. Thanks everybody. Bye bye. Have fun. Love you.
Bye.
Adderson says thanks for the stream, Lens. You're so sweet. Thank you, Adderson. You warm my heart.
Bye-bye.